Hi, welcome to our math. Today I'm doing a series of videos on linear equations, and this video is going to be on scatter plots and using Excel to help. So in this video, it says the following data is on the life expectancy of people in the US. Let the year 1960 be represented by the year 0. So this is important because we don't usually use 1960 or whatever the year that the data starts be where we start, because then our graph would start 1,960 units over, and we really want our data to start at the origin. So if 1960 is 0, then 1970 would be 10, and 1975 would be 15, and 1980 would be 20, 85 would be 25, 1990 would be 30, 95 would be 35, 2000 would be 40, 45, 50, and 55. This right here is an important column, but in all honesty, we're not going to use this column. These are the two columns that we really care about. This is what we would graph. This is what we use for our data points. These are the only two columns we're going to utilize for our data. This red column, the one I just highlighted, this is what we use for our interpretation. We wouldn't say 25 years after 1965. We would say in 1985, because people don't speak 25 years after. So we would use the actual year in our interpretation. However, when we do any of our math, do any of our creation of a linear model, when we do anything like that, we'll use the modified data. But the thing is, this isn't an exact straight line. Real data is dirty. Real data is going to be ugly. It's not going to all fall perfectly on a line. So what we want to do is we want to use Excel. Now, I actually have put all of this over onto Excel already. And I did all of that subtraction, but Excel is beautiful. I could come here and I could say this block is equal to this minus 1960. And it'll subtract it for me. And then I can bring it over till I get this little black plus sign and just bring it down. And there you go. If I really wanted to, I could center it like I did over in Word exactly the same way. And I have everything there. I have the year and I have the population. Okay, so everything's done. Quick, easy peasy. It was much faster this way. I didn't have to think. What I want to do in Excel is I want to create a scatter plot, and then I want to create a line of best fit, and then I want an equation of that line of best fit. So I'm ignoring this. This is going to be ignored. Once again, I'm going to highlight that red. That is there to help create my input column, but I'm not going to utilize it. I want two variables, input and output. So I'm going to highlight these two columns, the ones that I want, my modified input and my output. Now I'm going to come over to Insert and then come over to my charts and choose the chart that looks like a scatter plot. I am using a PC. If you have a PC, it's going to look a lot like this. If you are using an Apple device, you are going to also have a chart table with a scatter plot, and it's going to be very similar to this. And you're going to find your scatter plot with the scatter and click scatter plot. It's not going to be a lot different. I'm going to change this to, what do we have? The following data is life expectancy of people in the US. All right, so I'm going to change my title to just that. Life expectancy of people in the US. Always title any graph, any chart, anything you're going to do, you want to title. But I also want to label my axes. I can come over here to where it says quick layout and choose the first one. The first one will give me, it tells me chart title, legend, horizontal axis, vertical axes. It gives me all of the things I have in that layout. And I can choose that one if I want. And that's a great one to have. If I take that, I'm going to get rid of this key. Just hit delete on my keyboard because I don't need that. I only have one item. And then I'm going to change my title to years since 1960. I might put T because that'll be my variable. And then I'm going to change my title or my axis, my output to population. And maybe P for A. Oh, that's funny. Ah, up arrow. Population. Now, on my computer, I have this green arrow. I could have chosen this over here with my green plus sign. Not all computers have that. If you are working on an Apple, I do not have an Apple device, you will have up top an item that says chart. And then where I have this word chart styles, about an inch or two over, you'll have something that says axis labels, axis titles. And under that, it'll say horizontal axis and then horizontal label. And then you'll get a box and you can type in year since 1960. And then below that, it'll say vertical axis and then vertical label. And then you'll put population. So you'll just have something right about here, about halfway to 2/3 of the way over, that says axis labels. So it's a little bit different on an Apple. All right. So now I have most of this done. I have my chart, I have my titles and everything. I probably should have mentioned this from the start. If you are using an Excel that's in a browser, you'll know that because the top of Excel will have a URL. The next thing we're about to do won't work. The Excel version, the browser version of Excel does not have all of the functions. You have to have a downloaded version of Excel to get this next part. All right, I'm going to click on a data point and then I'm going to right click. I'm going to give 3 sets of directions. If you have an Apple, you have to do a 3-finger tap to get this. So I right clicked. Apple users have to 3-finger tap. And I'm going to click on add trend line. So that's going to take care of most of you. For some of you, there is a function here that says, I think it says settings, or it says, there's another word here for details on your points. If you don't have add trend line, the bottom one says like settings or details on the points. You have choices of exponential, linear, logarithm, polynomial, power. We are dealing with lines, so I'm going to say linear. Make sure down here at the bottom, you choose display equation. If you don't display equation, you won't get your equation. So line down here at the bottom, display equation. If you have that third choice with settings, down at the bottom of your table, there's going to be a little slide bar that says add trend line, and under that will be display equation. So that's that third option. If you do have the Apple with the trend line, the menu on this right will be exactly the same. All right, so this is everything you need to do on Excel. You need the population, you need all the labels, and you need this equation. So I'm going to see how I have this all selected. I am going to come really close to here. I am going to hit, I'm going to do this from Word. In Word, I am going to come over to Insert, and you see where it says screenshot, I'm going to click screen clipping. And when you hit screen clipping, it drops Word down and you get slow plus sign. And I am going to do a clipping of this. And this is just going to do a screenshot. That's very interesting. I am not sure what happened with that screenshot. Oh, I know what happened with that screenshot. Let's paste it here. Nope. All right, we're going to do that again, not within a table. Screenshot, screen clipping. This is the screen clipping I want. Okay, here we go. Copy this. I don't know where my mouse was before. So it says over here, create a scatter plot with a trend line. I'm going to put this one's under B. Quick layout. So that's where I want this. Okay, create a scatter plot, find a trend line, write the equation. So y equals 0. It says 2 decimal places, 1.0.17x plus 69. It says 897, so that's going to be 90 if I'm rounding to 2 decimal places. What is the slope? Well, slope is m equals. So I am going to say m equals, but I don't want a capital, m equals 0.17. What does it mean? Every year since 1960, the life expectancy in the U.S. increases by 0.17 years. I always have the word increases in a slope because slope is our action word. All right, and what is the vertical intercept? I always put this as a ordered pair, so 0, comma 69.90, 0. Okay, what does this mean? In 1960, because that's what that 0 is, the life expectancy in the US was about 69.9 years old. Okay, so then use the regression line to predict the life expectancy in 1955. So from 1960, that means that t or x or whatever our variable is equals -5 because it's 5 years before 1960. And so we're not using the chart, we're using our equation. So y equals 0.17 times -5 plus 69.90. And the thing is, if you don't show work, you're not going to get credit. You can't just say, hey, it's this because I know it's this. If you always have to show work. And that's a big thing. Miracle answers are never good. So 69.05 years. It doesn't say write a complete sentence. It just says give an answer, make sure you label it. All right, use the regression line to predict 2020. 2020 minus 1960 equals 40, 50, 60 years. So then we have y equals 0.17 times 60 plus 69.90. And again, notice I'm showing all my work, including finding that 60. So this one is 80.1 with a label. It says use the regression line. So can I get out more spaces here? Use a regression line to predict the life expectancy of 78. So this time it's 0.17x plus 69.9 equals 78. I'm going to subtract 78 from both sides. All right. So 0.17x equals 51.1. Then I'm going to divide by 0.17. X equals this 51 is wrong. Sorry, minus 69.9. This is 8.1. $47.6. What does it say? It doesn't. 47.6. But it says which year. So we have to make sure we know what we're answering. So we then add 1960, which makes this, we're going to run that up to 48, so about 2008. Do you think using this model would be accurate for predicting life expectancy in 2050? Why or why not? So if we did 2050, this is already 2050, 5090. If we put in 90 into our equation, we get, yes, no. I mean, this is a personal question. The thing is, life expectancy won't be linear forever. So this question becomes personal answer. I can't answer this one for you. You're going to have to think about it yourself. But the thing is, linear equations eventually head off to infinity. It's going to outpace the life expectancy for the average human. So it will not forever be valid. So there's a point at which really the linear model is not the best model for life expectancy. All right. I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.